Hello, this is Dr. Paul Cottrell, and I'm going to be talking quickly about the problems with the heart, okay, regarding um, this crisis. All right. Now, there are several different things that could be happening with the heart, but I'm going to focus on the electrical signaling part of this. So when I'm talking about the electrical signaling, it's not mutually exclusive. It's not the only thing that's happening. For example, there's myocarditis, right? There's pericarditis, there's endocarditis, there's vasculitis, so there's a lot of things that are happening cardiovascularly that can lead to problems with controlling blood pressure, um, controlling electric signaling, controlling the actual contraction of the heart, the what is called the ejection fraction. Um, um, if you already have, some sort of cardiovascular disease, it's going to exacerbate this problem. So, keep in mind, there's a lot of different things that could be happening to the heart relative to this crisis. All right. For a multitude of reasons. All right. Now, but I wanted to focus more on the electrical signaling thing here. Okay. We have nodes in our heart, the SA, the AV node, that get a signal that tells the heart to contract. All right. The SA node signals to the AV node, and then the AV node it propagates an electric signal throughout the septum and the lower part of the heart, the ventricles. All right. So and that's the big contraction in the heart. Okay. Now electrolytes can affect the heart. Too much sodium, not enough sodium, too much potassium, not enough potassium. So electrolytes has a big part to play in this. Okay, so there are different receptors, we've talked about, that have this affinity to the spike. And these receptors are like ACE2, but specifically that I want to talk about is CD147. This is a receptor that's on platelets, on red blood cells. They're on epithelial tissue and also endothelial tissue. And we around the aortic arch, at the top, at the kind of the apex of the aortic arch, all right, there are baroreceptors. We have chemo and baroreceptors in our body, especially in the carotid and around the aortic arch, that are sensing pressure and pH levels and stuff like this. So the chemo receptors are sensing chemical changes that are happening in the blood, and then there's the baroreceptors that are sensing the stretching or lack of stretching of the actual vascular system. In this case, it's the stretching of the aortic arch at the apex part of it. And then in the carotid area, we have these baroreceptors. Now, we have a signal that's coming from the carotid through the cranial nerve 9 that signals to the medulla. All right, the medulla, you have your brain and the brain stem. So the medulla is right below the pons. All right. Now there are a set of nuclei in the medulla that are receiving this signal from cranial nerve 9 that is sending an afferent signal from the baroreceptor to the medulla. And then from the medulla, it's sending a signal to the heart for pumping. Now, there's two signals that are coming. There's a sympathetic and there's a parasympathetic. The parasympathetic is coming from the efferent of cranial nerve 10. Now, we also have receptors that we also have a signal from cranial nerve 10 in the afferent, sending us another signal to the medulla. So the medulla is getting two signals. It's getting signals from the aortic baroreceptor and the carotid baroreceptor through the carotid is cranial nerve 9 and the aortic is cranial nerve 10 to the medulla. Then the medulla will send a signal based on that information. Do I need to pump the heart more or less? All right. Usually when you have higher blood pressure, assuming there's no disease state, you have higher blood pressure, then the heart doesn't want to continue pumping because it could create too much pressure and have some sort of blowout. So it usually brings down the heart rate. So your cardiac output is based on, your heart rate and your cardiac output, or your stroke volume. So your cardiac output is your heart rate times your stroke volume. So if you have too much blood pressure, then what's going to happen is that the body has a mechanism to bring down that cardiac output by bringing down the heart rate. Okay, so cardiac output, heart rate times stroke volume. Now, when the barrier receptors at the aortic arch or at the carotid artery signal too much, then cranial nerve 9 and cranial nerve 10 will go to the medulla and say, slow down. And that slowing down is activating the efferent cranial nerve 10. Okay. Now, if we look at long COVID, many people are talking about tachycardia. Well, tachycardia is basically a speeding up of the heart, and that signaling of the vagus nerve is being disrupted, and not signaling a slowing down of the heart. It goes into default mode and stays at a sympathetic, faster rate. The reason why this is happening in this crisis is that we have CD147 in this barrier receptor zone of the carotid, all right? And when those are activated and there's an inflammatory response that's taking place, the barrier receptor is not working correctly to send the correct signal, the afferent signal, to the medulla for proper heart rate, either parasympathetic or sympathetic. So through the activation of CD147 and the inflammatory response that takes place through that, there is this disruption. Now, take it one step further. Again, what I said, there's other things that could be happening with the heart: endocarditis, myocarditis, pericarditis. A lot of things could be happening, But let's say take the example where there's no pericarditis, no endocarditis, and no myocarditis in an athlete, and they're running on, let's say, a basketball court, and their heart rate is pretty high, right? And their blood pressure's higher, right? But what happens is that if they have too much of this activation of this CD147 through the spike, and there's it's been proven that when CD147 has been activated, there's an inflammatory response that takes place. When that happens, it can perturb the system in such a way where they go into a rhythm in the heart that it shouldn't be going into. There's an arrhythmia that could be taking place. They, without seeing the EKG, you don't know if it's atrial, fibrillation or atrial flutter or ventricular, some sort of ventricular arrhythmia. But a lot of these cases seem to suggest that it is some sort of what is called a supraventricular arrhythmia. So that basically means is there an electrical signal that is disrupted, and I explained why, because the signal going to the medulla is not being processed correctly, based on the barrier receptors, and it will go to default mode. So, and then if the heart is, not getting the correct signaling, you can get this arrhythmia or super, high tachycardia kind of thing. So these athletes, some of them, I think that aren't showing positive for endocarditis or positive for myocarditis or positive for pericarditis. Some of these individuals are having this mechanism being activated where their heart goes into an arrhythmia. There's a video that took place on Twitter that's showing a basketball player. I don't know the team. He was wearing, I believe, blue jersey, and he was defending, and the other team shot the ball. There was no real contact with this person, no blocking or anything. And he just stopped and grabbed his chest. Now you got to remember that people that are especially running back and forth on a court, your heart rate's going pretty rapid. I think that's what happened to this particular individual. This just happened 2 days ago or a day ago. That's been posted. I don't know exactly when the event happened. That's the kind of thing where I think it's an improper signaling of the medulla through this carotid baroreceptor and aortic receptor. And so if you're an athlete in college or professional, or in the military, one mechanism here is to disrupt that signaling through activation of the CD147 and that inflammatory response that's going on in that baroreceptor area. The question comes in is that, are there CD147 specific medulla activation that's taking place? So the medulla is part of the brainstem, and you have these are neurons, right? And then there's a nucleus. Now, in those neurons, are there CD147? I don't know. There might be. I don't know. So, but it seems to me that there's the inflammatory activation of CD147 in the baroreceptor of the carotid and the aorta that's disrupting the signaling of the vagus nerve, cranial nerve 10 and cranial nerve 9. And when you have that would, somewhat explain some of the problems that we're seeing with long COVID. So keep that in mind, all right, that there are many different things that could be happening with the heart. The vasculitis, pericarditis, myocarditis, endocarditis, and improper signaling. And through this video, I just explained how one mechanism of how that could be taking place. Thank you for listening. Please subscribe to all my channels. I have 3 YouTube channels. I have Brighteon, Bitchute, and Rumble as my backups. I can keep some videos up if I'm somewhat generic in the terms that I use. But there's other videos that I go full bore on, some of the detail about, certain things that have been happening. And those things get strikes, and I have to make sure that the channels stay afloat so I can reach a larger audience. So the best way to see my work is watch the premieres on YouTube. Some of those videos will stay up, others will be taken down, and you can see the backups on Rumble, Bitchute, and Brighteon. Please help support my work by going to Patreon and being a subscriber on Patreon. That helps. Please go to my website, the-studio-reykjavik.com, the-studio-reykjavik.com. All the links are in every video's description, so it's very easy to find my stuff. And donate on the homepage at the bottom. You can donate through Stripe or PayPal, but you can also donate through Buy Me a Coffee. And by doing that, you help support my work. But better yet, please go to my store, the-studio-reykjavik.com, and look at the health supplements that I have. I have nano silvers. I have a plethora of health supplements such as vitamin C and B complex and resveratrol and turmeric and digestive enzymes, good night formula. I have a lot of stuff, pre and probiotic, lignans, which is good in controlling your hormonal levels. What I do is I mix the lignans, it's a powder, with my probiotic, and I take it with my, I have homemade hummus, and I eat that with the powder every day. So proper nutrition, proper supplementation will lead to better health outcomes and increase your immune system. And I also have a very strong antioxidant, C60. You want to take strong antioxidants to be able to soak up those reactive oxygen species. That reduces, when you don't soak up those reactive oxygen species, your ATP will go down. The health of your mitochondria will go down. Your energy will go down. But soaking those up with C60, your energy will go up. Your mitochondrial health will go up. When you have better mitochondrial health, you'll have better cellular performance, and you will also increase your thinking. You need a lot of mitochondria, healthy mitochondria in your neurons to be able to do what they need to do, because it consumes a lot of ATP. Well, if you have really good mitochondria and not a lot of this inflammation that is being caused by reactive oxygen species, you will fare a lot better. You'll age slower. Okay, it's very simple. Then I have an all-natural deodorant in citrus scent and in peppermint tea tree scent. There's no aluminum in it. Get that. That's a really good product. It's made by Rainbow Herbals. And then I also have a toothpaste that has no fluoride. It's a nano silver toothpaste. It's going to be the best toothpaste that you've ever used. It whitens your teeth. It neutralizes pathogens. It reduces cardiovascular disease. It reduces the gingivitis. It reduces the gum inflammation. If you try that toothpaste, you will never go back to another toothpaste. So thank you for listening. Thank you for supporting my work. And hopefully you understand one of the many things that can happen with the heart dealing with this crisis. Thank you for listening. Have a nice day.